everybody, and welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over scientific notation, specifically the operations of addition and subtraction. First, it's important to remember what is scientific notation, how we move with scientific notation to be able to accurately do our addition and subtraction. So if we take a look, to add and subtract numbers in scientific notation, we have to know that the n value are our exponents. When we say n value, that's our exponents. Our exponents must be the same. So if they're not the same, we have to make sure we create them to be the same so we can add them together. It's almost like when we use variables, they have to be the same variables to combine them. Like our like terms, we have to make sure our exponents are the same to be able to add them together. So we are going to change the exponents of the smaller one to be the same. I know other teachers might make the bigger one into the smaller one. I do the opposite. I make the smaller exponent into the bigger one and then continue. So something we have to remember, one of the most important parts of this, is when we're moving our decimal place to the left, we are adding 1 to the exponent. So if we have to move our decimal over, we're going to add, or if we want to add to our exponent, we have to move it to the left, vice versa. Same thing down here. Moving our decimal place to the right subtracts from the exponent. So if we need to subtract from the exponent, we have to move the decimal place that many times over to the right. So let's apply this. Let's see what we have to do for scientific notation when we're doing addition. So an example for addition is we have 6.2 times 10 to the 6th plus 9.8 times 10 to the 4th. One of those most important parts here is to realize which one's my smaller exponent, my smaller n value, and that is 4. So I'm going to make the 4 become a 6. Well, how does 4 become 6? I am going to add 2 to the exponent. Like we saw before, if we're adding to the exponent, we are moving it to the left. So I am going to move my decimal place 2 to the left, and then we can make this exponent times 10 to the 6th power. So that is going to become 6.2 times 10 to the 6th plus 0.098 times 10 to the 6th. Now we have both our exponents the same. We have our 10 to the 6th and 10 to the 6th. So now it becomes a little bit nicer. All we have to do for addition of scientific notation is add their factors. We'll take our factor of 6.2, our factor of 0.098, and we're going to add them together. And then our exponent just stays the same. So we're going to have 6.298 times 10 to the 6th. Once again, I added their factors together and kept my exponent the same. Unlike when we do multiplication and division where we're changing that exponent, we already changed it up here. We made sure it was equal, so we're just going to combine our like terms, like I said before, and it becomes 10 to the 6th power. Let's take a look at another example to make sure we are solid on this topic. So now I have 3.8 times 10 to the 1st plus 9.5 times 10 to the negative 2nd. And we have to think here, which one's my smaller exponent? Oh, the negative 2 is the smaller of the two. Now I have to get negative 2 to become 1. Well, how many away is negative 2 from 1? If I add 3 to negative 2, I get 1. Once again, our integer operations are so important here. I add 3 to negative 2. When I'm adding to the exponent, just like we saw in the last problem, I'm moving 3 to the left. So I move the decimal 1, 2, 3. So now the new problem is going to become 3.8 times 10 to the 1st plus 0.0095 times 10 to the 1st. This writing is just everything I just verbalized, but it's just here if you want to reread it again. But we added 3 to the exponent to be able to get the exponents to be the same. When we add 3, we move 3 to the left, and this becomes our new problem. Just like in the problem we saw before, we are going to add these factors together, and I'll get 3.8095 times 10 to the 1st power. Our exponent stays the same, and we just add those factors. Let's take a problem with subtraction to see what we are going to do there. So the same thing is going to happen for subtraction. We are going to want to change the smaller exponent into the bigger one. The only difference here is instead of adding the factors, we're going to subtract, which doesn't that make sense? When we're doing scientific notation addition, we add. When we're doing scientific notation subtraction, we subtract. So let's see, I have -6 and -3. This is where we really need to think of our number line. Which one's smaller? Which one's further away from 0? Well, -6 is further away from 0. It's smaller. A lot of people get confused because they're like, well, 6 is bigger than 3. No, but when we're talking about our negatives, -6 is smaller than -3. So I want to get -6 become -3. If I add 3 to -6, I get -3. Just like we saw before, if we're adding 3, we have to move 3 to the left. So I'm going to go over 1, 2, 3. And my new problem is going to become 0.00888 times 10 to the -3rd minus 5 times 10 to the -3rd. And that's what I have right here. Now we are going to take our factors and subtract them. So 0.00888 minus 5, and that gives me -4.99112, and we keep the exponents the same, which is times 10 to the -3rd power. So we're seeing a pattern here. Every single time we make the smaller exponent into the bigger one, we move that decimal place over to the left a certain amount of times, however many we need to get the exponents to be the same. And then we either, based off of the problem if it's addition or subtraction, we are going to add or subtract the factors, keep the exponent the same, and that's how we do scientific notation for addition and subtraction. So I hope this video was helpful to make sure you are understanding how to do this concept.